Let me introduce you to my Warco drill press. But could it be improved? Welcome back to the workshop. So in this video series we're turning this drill press into this. So we managed to make pretty good progress so far. So you can see we've got the ball screw in for the Z-axis, we've got those big box sections in there, custom control cabinet here on the front here, we've got our 3-phase motor at the top there, and we've made some of the parts for the Z-axis height adjust mechanism. We made a custom control box to control everything, the inverter and all the circuitry in there. And in this episode we're going to be installing this mystery part here that you can just see off to the edge. Can you guess what it is? Looks like a digital readout. Ah, don't give it away. You do know it's written in the title, don't you? Now this little box just arrived, which has got that on it, YH3, and something else, I don't know what that is. And it's got that written on it. And looking inside, we've got a digital readout. Fabulous. So we've got the instructions for it, and see, that's the cover. And in here, there's quite a lot in here, but we've got digital readout. And this model is, this is a Yihua GD. Don't know what GD means. YH800. So we've got our 3-axis display there, X, Y, Z. This will be calculator and increment absolute modes up there. A range of functions, we'll dive into those in a minute. Our calculator, or we can type in our numbers, our setting on our readouts. Yeah, looks good. On the back, yeah, pretty standard. So we've got our 3 inputs. And I did have a look for a 4-input one, just in case I wanted to put one on the quill. But they only sold the 3, the 2 and the 3. 2 for a lathe, 3 for a milling machine, so this will be fine. We've got the earth point there, which you need to put on, mains and on off switch. Okay, looking good. What else have we got? That's our 400mm one. Looks like another 400mm axis. Looks like another one. Next one looks like the cover plate. That's the 400mm cover plate. Looks like, yeah, there's another one. That's another cover plate. Is that it? Is that all the plates? Oh no, there's one more. Yeah, there's one more down there. Yeah, that's the 150mm cover plate. Is that it? Oh no, some more. Get that in there. So in total we have the 400mm scale, got 2 of those, 150mm scale, and we've got the covers that go with each of those, so they're the large ones. Got 2 of those, we've got the cover for the small one, we've got the arm that holds the display itself. We'll go into more details in a minute. Instructions, the cover. So they also sent this power connector, so we've got this type of connector on the end here to the IEC plug that goes into the back of the display, and then to adapt this to UK plugs you've got, for some reason they sent 4, and as far as I can tell they're all identical. Maybe they thought we needed one per scale, but there's only one of these that runs the display. And obviously you then would connect that into there, and that would allow you to plug it into the wall. Now that would work, but I strongly recommend, if you're in the UK, just to buy one of these. They're very cheap. This is a UK plug already molded onto the IEC connector there, and then this one will meet the British standard. There we are, it's down, I don't know if you can read that, no, 13, I can't read it, 1363, right at the bottom there, no, there we go. Make sure you meet the standard there. Then you've got the fuse in there, it's all moulded, you've got the grips here, so it's much more difficult to get your fingers around there. You've got your strain relief at the bottom there. Very cheap, so that's what I'm going to do, but I'll leave it up to you, but that's what you get anyway. Before we get started, just a couple of things to point out. First is that Banggood sent me all this stuff free to include in a review, so I didn't pay for any of this. Although when it came into the UK, although it was marked up free, you know, zero charge, I still got charged £35 for handling and import duty, something. So I phoned up the tax office and I explained this was for a review, and it was free, and they said, oh, okay, so they waived the cost. No, I thought about it for a few minutes and then I just paid it. I mean, £35 for everything we got here is still pretty good value. The other thing to point out is when you order the display and these linear scales, they are all separate orders. So you'll select the display, and then you might scroll down and select a linear scale, another linear scale, another linear scale, and you think you're adding them to the basket to make one order, but it's just replacing them. So you get to the end, you think, oh, that's good value, but you're only basically just buying the last one you just put in the basket. So they need to be separate orders. I guess it's the way that the website handles combinations that are user selectable. So you put an order in for the display, a separate order for this one, separate order for this one, and a separate order for that. I've seen a couple of people caught out with that. I don't know what Banggood can do about it, but just be aware of that if you order it off their website. So before we dive in, I just want to give you a little overview and just my first thoughts on the sort of quality of the items. I think the scales in particular are really nicely made, nicely finished, aluminium, possibly with some stainless material in there. Everything's nicely finished, laser etched with their logos and some instructions on there, some specification. You get the protective cabling as well, and then the linear head. It's got this little red plastic guide on it as well, just to help it along. It does have some freedom of movement, that's deliberate, so it gives you some alignment, but it slides nicely. And you've actually got double seals in there, these yellow parts. There's another one lower down, which if I took the end off you could see, just to try and keep the dust out. But it is recommended you put the cover on as well, just because if you get anything inside here, it's going to damage, or it's going to give you a misreading. So you want to keep that nice and clean. So the scales are really nicely made and they feel really nicely finished. So hopefully they'll work well. Not so good though is this is the mounting bracket that holds the display on. First I thought it might be a zinc casting, but it's extremely light, so I don't think it's zinc. It's obviously just been chromed over the top, but as you can see, it's not exactly beautifully finished. So I don't know, it's a complicated part. I might make another one, or I might take all this off and maybe spray it black or something like that and clean it right up. Be a bit of a shame to put something like that on the machine, but I mean it'd be functional, I'm sure, and probably strong enough, but just maybe the finish could have been a little bit better on that. Alright, so let's unwrap it, get it plugged in and set up a couple of the axes, and I'll take you through all the options on the display. Oh, yeah, it didn't really all just come out of that box. It actually arrived beautifully packed in these nice long boxes, plenty of packing foam in there as well, was nicely wrapped just in case I get into trouble and made it look like they just chucked everything in that box. That was me just messing about. While we're here, there's a number of other connectors as well. There's a 232 interface. It's not on this model, but certain models will have that. EDM if you've got an electric discharge machine. There's a dedicated display type for that. and there's a connector with its wiring. And you've got a couple of others as well. I think for the most part, for milling and lathe operation, with just a 2 or a 3 scale readout, you'll just have this style up here. As mentioned a moment ago, I'm just going to be fitting my own cable to this. Ultimately, I'll be cutting this off and then hardwiring it into the control panel, so when everything comes on, when the drill press comes on, this comes on as well, and it will run through its own fuse in there. But just for now, we'll just use this, get it connected. Okay, I've got it set up, so this will be my X, and this will be my Y. We'll just check the Z works, but then just leave that for now, and then we can play around with some other functions using these. So this is genuinely the first time I'm going to switch it on. I love doing this, because you never know what you're going to get, so fingers crossed, and we'll switch on now. So let's have a closer look at this DRO. When I was having a look around the Banggood website, I noticed this model, which looked like one of the new models, and they rearranged the keys from before, and they've clustered the X, Y, Z zeros together with the when you want to enter exactly where you are. So you can zero them here, or you can move to a location and actually type it in here, which is handy on the lathe if you cut a diameter and then you tell it what diameter you're at, and then you've kind of calibrated your position. So it just looked like a nicer layout, and some of the functions on here, or it looked like I had additional functions on here, and it wasn't a lot more money, maybe another £5 or something like that. So that's why I went for this model, and so far it looks quite nice. So starting the top corner here, this is what they call lathe mode. This is when you want to couple 2 optical scales together. So I guess if you've got something like a knee that has a scale on it and a quill, you might want to combine those to give you the total position or something like that. But this, if you want to combine 2 scales together to give one readout, and there's a couple of ways you can do that in that menu. This one here is if you're deep into a menu, like you're in a hole pattern, and you want to come out just to see where you are in absolute coordinates, you can do that, come out, see where you are, and then go back in without losing your position in that little bit of code. And then the next 4 are quite interesting ones. They're about how you can make the most of a DRO. So you can cut an arc, you can cut a slope, a hole pattern, or a set of linear holes. Now it's worth bearing in mind that these 2 functions don't only operating in the XY plane, but they'll also operate in XZ or YZ. So it's got a kind of Z function, so you can have an arc in this plane as well, or a slope. They're not just sort of 2D patterns. Now on my drilling machine, that's not really going to be very helpful, but if for a milling machine, especially if you haven't got CNC, that could be quite a nice option. There's keys for stepping through menus and cycling through SDMs. We'll come on to those in a minute. The half function, really useful function. I'm sure you've seen lots of people use these in videos where you touch off one edge of a part, go to zero it, go to the other edge, and then press the half, and it will bring you, the 0 is then the center of that part. So quite a popular button that you might need there. The next one is for your units. So you've got millimeters and inch noun, an old English unit based on the length of the king's. Wow, people still use that. Okay, next you've got incremental or absolute mode. Absolute mode is where you'd originally touch off the part, say the bottom left corner, your 0, 0, that's your world coordinates, so that stays always the same. Incremental is then you might move to a certain location on that part, say 100 millimeters in X and 100 in Y. Go into incremental and it momentarily creates a local axis system that zeroes it at that new location, and then you can do a relative movement, say a hole pattern or something around that location, without losing the 0 of the complete part. Now that's a kind of general everyday use for that function, but they also have some specific, what they call SDM, I'll call them subdatum memories, but they have another name for it which has the same letters, secondary something. It's another set of temporary positions on the part. We'll go into that more in a little bit later. Calculator enables you to use some of the calculator functions. There's a little bit of a limit to the display. You know, you can't have like a huge number of decimal places. You can't have to the powers of stuff like that. But you know, you probably got a phone in your pocket with a calculator on it anyway. So that's that function. And then this one here is. It depends if you're in the subdatum menu, you can step through the options there, or when you're cutting the arcs, there's another functionality built into that. So we'll go into that in a little bit more detail. Clears the display. Now, if you want to go into the setup menu, they usually got a magic key you have to press. On my lathe, you have to hold down the decimal point. On this one, you hold down Enter. When you switch it on, it will go into the setup mode, and there's about 12 or so different options you can go through there. The scale resolution, scale direction, things like that. So let's have a look at those now, because that's one of the things you might want to set up when you first get it. So we'll just switch it off. And then on this model, you hold down the enter button while you're switching it on. There we go, and we've gone on to setup mode. So we've got cell type come up on there, but confusingly in the instructions it says cell sys. This is the number of linear scales, so we've got 3 on our unit. Direction, this is which way is positive, so you can switch it negative or positive. So if you move the machine in the positive X direction, but the display is going in negative because of the way you got these set on the machine, you can flip it round so you get what the direction that you want it to go in. So you're basically switching negative and positive on here, so it goes the right way. Linear compensation is a way that you could override the calibration in these and give a change to the readout. So I guess if you've got a really accurate way of measuring more accurately than 5 microns, or you're not happy with the accuracy of these, there's a way you can put some compensation in there. It's kind of a calibration. They don't recommend you do that and don't touch it, which I think would be my advice as well. My experience, these are plenty accurate enough, so I wouldn't touch that. Radius or diameter mode is very handy on the lathe, so if you move the tool in 1mm, you're actually going to cut 2mm off the diameter, so it might make sense with the readout to show double the actual tool movement and go into diameter mode. That's the mode I have my lathe set in, but it depends on your preference. Z-dial is quite an interesting, clever function. So if you've only got a 2 readout DRO, but you've got a hand wheel to move something in Z, let's say, if you tell it the thread pitch of that, when you're cutting some of the moves, some of these arcs and things that go up in the Z plane, it'll try and help you out by telling you how much to move that hand crank in Z. So that's in here. Resolution, we're going to check that in a minute. These should be 5 micron scales. Now I don't think Banggood sell them, but you can get 1 micron scales. I'm not sure why you'd want to go that far. 5 I've found is perfectly adequate, but it's available there. STM direction, so we'll go into that in a little bit more detail. It's about, in a nutshell, I guess it's about how you want to think about setting those datums. Do you want to consider yourself already at the datum and how far it is back to the master origin, the main absolute 00, or do you want to go to the master origin and tell it how far it is to that sub-datum? Depends on how your mind works and how you want to set that, so there's different ways you can do that. The next few are EDM. I don't have an EDM display or an EDM machine. The electric discharge machines are fascinating to watch. They use a discharge of electricity, sort of sparks, to erode its way through material, and you can get extremely accurate parts with that. Probably not really a hobby machine, but there's a display available if you have one. These two slope and step modes are if you don't have enough encoders and you have a Z-axis movement as well, as I mentioned a minute ago, you need to set some of these up so that it can control how you move in the Z-axis using the hand wheel, because you haven't got an encoder on it. So that's what those are for. Lathe mode is if you want to add up 2 displays to give you a result into one of the other displays. So if you want to add 2 scales up to give you a total result, you can do that. So I guess there could be some advantages to do it that way. Axis type is whether you've got a glass optical scale, linear encoder, and a few other types as well. And then you've got things to do with the angle mode that you want to specify. And it kind of comes down to if you want to go 0 to 360, or you want to have minus numbers in there, or you just want to go to 180 and then have it as minus down the other side. I guess it's a preference thing there. Then finally you've got clear all the settings, if you want to go back to the defaults, and then exit. So not too many to go through, and you can see why I showed you it in the book, because if you walk through there you kind of lose where you're at. So I think just let's go and check the resolution, just make sure we've got that set okay, and then I think we're done with the initial setup. So we need to go down to the resolution option now. I think it's a little bit confusing on all these kind of systems. You actually go up in the menu, so we're on cell type and we needed to go, that was the direction, linear compensation, don't recommend you touch that one. If you want radius or diameter mode, that's if you've got an independent Z axis, to set that one up. Resolution, right, so we'll go in there, And yeah, we're 5 microns on each one, so I won't touch those. We'll just come back out again. Yep. And I think that's all. So we'll go to the exit, which is down. There. Oh, one more. There we go. We're ready to go. Right, let's just actually check they work before we go too much further. So we got this one. That's set to X. So depending on how you got this configured on the machine, so which way is that going? Yeah, as I come this way, it's going negative. Yeah, okay, that's fine. And then I think I've got this one hooked up to Y. So that'd be the table going that way, more positive. Yeah, in that way. So that's the right direction, but you can change them. Z, we haven't got. Oh no, we have actually got that hooked up, haven't we? That's that one down there. Okay. I'd have to think which way around the table is going to go up and down. That will go down. Alright, so that needs reversing. That's fine. Right, so we'll zero those out. So the idea, now we're in absolute mode, the idea is you go to the corner of any given part and pick up off one of the edges, say with an edge finder or wiggler or something, and then we'll just zero those out like that. So now we know we're at 0, and then we can move the machine around, yeah, like that in X, that's fine. Move to our whole position that might be at 20 in X or something like that, and whatever it is in Y, let's say 10, whatever, something like that. So we're now at that position, drill a hole, tap, whatever, ream. I'm sure you've seen all this before. To be honest, I think 99% of the time, especially for hobbyists, that's probably all you'll do. You'll touch off the edge of a part, then move to where the drawing says you've got to build a hole or some kind of feature, and then you'll drill that hole or tap it or whatever. That's certainly what I spend most of my time doing anyway. But it's nice to know you've got a host of other features as well, should you need them. So those of you following on my drill press build project, I'll put a link down in the description below so you can follow the series. You'll know that I've still got quite a lot of parts to make, like the table, and I'm just finishing off the Z-axis at the moment, the up and down mechanism for it anyway. So I can't put these on my machine yet, but what I can do is set up a little demo down here, just to give you an example of how you use some of these functions. Okay, so let's say we just cut this part out here and we want to drill and counterbore some of these features in here. So we'll use an edge finder like this, and what this does is it's spinning, and when it touches against the edge of the part, there's a little bit of friction generated and it kicks out, so you know you're half the diameter away from that. So you could type that half diameter in, but we're just going to zero it because the two cancel out when we go to each side. So we'll come along here, it kicks out when we're against that edge there, so we would zero. And then we'll move the machine over to the other side, so I'm going to simulate that by moving this over here. So let's say we've come in here, now we've touched off that side and it's kicked out, so now we're there. So now what we need to do is just half that to get to the center. So we'll hit our half mode, and we're on half the X. And now that shows half that value. So effectively what you do now is you move it back to where it would show 0. This is a bit fiddly, but there we go, somewhere around there, give or take. Yeah, oh, that's good. So now we know we're in the middle there, and then we repeat for Y. We touch off there, we go across the other side and half it. I'm sure you've seen all this before, so that's our half. So now we know where 0, 0 is in there. We might alternatively want to set our coordinates just down the bottom here. So the way we'd do that is we just come in here, we touch off. So we'll move it like, let's say we're doing the X first, come in like that. We're touching there. Now we know the diameter of this, 10 millimeters, so we then need to tell it we're at X, we're at, yeah, the center point's there, so it's 5 millimeters behind, so we need to be X 5 minus, oh, where's the plus minus button? Oh, it's down there. Slightly different on my lathe one, there we go. So now we're at minus 5 in X, and then we do the same for Y. We'll come in there, let's say we're approaching from that side, and we're just touching it, so now we're at minus 5 in Y, so we say Y 5 minus, and we're there. Now if we were to move the machine 5 in, 5 there, the center of this would be directly over the center of that. So let's just try and simulate that. Oh, go the right way, somewhere around there. I'm not going to get it on 0, am I? Ooh. Steady hand. one more. Okay. So we've moved the machine over there. There's 0, 0. And so on the print, it would often datum two edges like that, and you know where each of the holes are. So just go across 20, up 5, and so on and so on. So to do these, you could just simply move to each hole location. Move it like that, like that. Gets you to each hole location, you drill countable, and you'd move around. So for something like that, that's probably what you would do. But there's a couple of other options as well. So this is in absolute mode. So in absolute, your world coordinates 0, 0, the total machine world coordinates are down here, or they might be in the center. There's something called incremental mode. So if we were to go back to our 0, 0, I'll just short cheat. So imagine we're at 0, 0. We might, those four there might be, so that might be say 30 by 30. That point there might be 30, 30. Let's just draw that on, just roughly. So if we say that point in the middle is about 30 in X and 30 in Y, I'll just put a little A there for absolute. Okay, let's put AB, absolute there. So we might want to go up to that location. I'm not going to get this bang on, am I? But 30, 30, or near enough. And that'll do. Okay, we're just sort of simulating it. So we're at that location there. This is an absolute coordinates. Now we might want to go to, this is where the incremental part comes in. Because we know from that location, if we just go out, say 20, or up 20 there, those are relative to that center point there. So if we go into incremental, which is here, and then we can 0 each of those because we're at that middle point there. And now we can move our 20 each direction. This would be easier with the machine, but I think hopefully you get the idea. There we go, 20, 20. So we're now at one of the holes, drill that hole, repeat for all the others, and then when we're ready to come back to 0 again, we just go into absolute mode. So we're wherever we are in space there, and we walk all the way back to 0 again. Yeah, something like that. Yeah, we're back in this corner again. And then if we know where the center of those four is, we can go over to there, then we can go into incremental and do that local machining and then come back. So that's the idea of incremental and absolute. Now if you've got the idea of absolute versus incremental mode, so absolute is your total world coordinates, and incremental means just some relative coordinates relative to some location you've specified, then it's not a big leap to go to SDM. Now I call this subdatum memory, I can't remember what they call it in this menu, but it's the same thing. It's up to, there were 500 SDM settings, so you could have 500 different relative or sort of local coordinates stored in here. Now if you're a beginner, are you going to use that? Probably not. I mean, you might not even use the increment and absolute. I rarely use that function because I'm only doing 1s and 2s, and there's a small feature count on each part usually. But SDM is really set up for production, when you've got production operations with lots of features. So if we bring the part back into shot, so we've got lots of features to do. You might set SDM1 to be here, and 2 might be over here, 3 might be over here, 4 here, and you might have 5, 6, 7, 8, 9. And in each local place, so you go to that local coordinate and 0, 0 for that SDM, and there'll be a 0, 0 for that SDM, and then there'll be a range of features around there, which might be a hole pattern or some linear holes or something all around that local 0, 0. So as the operator, it might be easier just to think about those local numbers to move through, especially if you're in a production environment and you're doing it that way. So that's what SDM is about. It's a load of subdatums. Now there are people who also have used that for tool offset. So if you've got an automatic tool changer and you keep flicking through different tools, as long as you tell it that tool offset, you could use the SDM feature for that as well. So another really useful and really popular use for these DROs is for doing hole patterns. So we've got a nice hole pattern down there. Now this is a part I need to make for my drill press conversion. So you can see the stock we've got there, it's just a solid billet of aluminium, pretty chunky. So that's all got me machined down, and then I'll have some of these features put on. Now I'm going to be spotting these with my CNC machine, then I'll drill them, tap them by hand. But in future, when this is working, this would be a great use for this tool. So we've got our bolt circle pattern on a particular PCD, and it's nice, you can use the DRO to tell you where you might want to pick these up. So it just needs a few basic bits of information to get it going, so let's try that out now. Now the first thing to do is to move the machine to the centre of the hole and then zero it. So I should pretend we've gone somewhere, and we are at the centre of that hole. So we'll zero there, and then we'll go into our circle pattern, which is this one. The first bit of information it needs to know is the radius. So in this case we're on down to 28, so we're 14, so we'd type our 14 in. And then the next bit of information is the start angle. Now that could often be 0, so if your hole's down here, but it doesn't have to be. So you can see in this example our first hole starts at 45 degrees and then they're 45 spaced apart, and also they're not all the way around, but that's not a problem because I'm going to manually move between each hole and I can decide whether to drill it or not. We need to put the start angle in, which is she's going to be 45 in this case. End angle. Now if we put the same number in, it will just do a complete 360. Okay, and then how many holes? So we've got 1, 2, 3. We'll have to count that one. 4, 5, 6, 7. 7 holes. Actually, we'll have to count that to make it work well, I think. Let's do 8 holes. And direction 0 is clockwise, which is typically what you do. If you want to go anti-clockwise or counterclockwise, then you'd put a 1 in there. So yeah, we'll go direction 0. Okay, so we've got our first hole coordinates, and it's saying we need to move minus 9.9 and minus 9.9. So it's going to be this hole in the bottom corner down here. So what we need to do is move the scale until that goes to 0. Obviously this will be a lot easier on the machine, but we'll get it as close as we can. Yeah, all right, that's pretty good. Actually, it's quite nice that the display's over to the left. I didn't notice that before, showing us that we're in a sort of special feature mode. Alright, somewhere around there. So we're now over that hole. We'll do drill, tap, do whatever we need to. And then we go to the next hole. Now, on this one, is it up to go to the next one? Oh, okay. It's down. Next hole. So now we need to move. Okay, we're going to move it until these 0. Yeah, I won't do all these. I promise you I won't bore you. Right, here we go. Just give you the idea. There we go. Move to there about 0. So we're now. Actually, we'd probably skip that one out on this drawing, wouldn't we? We would have gone to go to hole 3, and with 0 and so on and so on. So if you've got as far as I know, if you've got a hole pattern like that that's got some missing, you still should put them all in, but you can just skip past them and go to the holes you want. And hopefully, as you move the scale, it will be pretty obvious which one you're over. You drill and tap them. So that's the whole function. So quite a nice feature, that one. And if you're in the middle of a function like that, you should be able to press, here we go, X, Y, Z with a little I, just means you want to come back. And what you'll see is these are on the left, which shows you're in a special function. So if I press that, it tells us where we are in absolute space as well, so we can get a good idea, make sure we're on track and we're where we think we need to be, and then we can go back into that again and carry on with the holes. So that's this little function here with the I and the X, Y, Z. When we've done all our holes, I think it was enter to come out. No, not enter to come out. Oh, a hole function again, that's it. There we go, we're back into absolute world again. Now the linear one is very similar, so we'll just go into that. I won't demonstrate it, but just show you the options you get here. So this is how far you want to go along. You type, I don't know, 50 millimeters. Okay, it's gone in. And then the angle that you want that to go along, let's say 45. And then how many holes? So I don't know, we'll just put 3. Okay, and then like before, here's where hole number 1 is, and you move the axes until you get that down to 0. I'm just moving the scale by hand again. Yeah, near enough, 0. Same on that one. And then you drill the hole at that location, then you say, yeah, I want to go to the next one. And again, 0 the scale. Yeah, again, I won't repeat. 0 the scale, drill a hole, and you'll end up drilling a diagonal set of holes with the spacing and the angle that you wanted. So probably not used as much, but a nice feature to have nonetheless. So I just mentioned two more features that you would use if you had a milling machine. So this one's if you want to cut around a large radius, and then this one is if you want to cut in a line that's not orthogonal, so you want to cut a particular angle and machine a piece off. Now obviously you can't operate the two hand wheels simultaneously to move either in a diagonal or on a smooth arc like that. So the way it works is you give it a number of parameters like the radius of the arc and your tool diameter, and whether you want to climb cut or conventional mill, and that's what these diagrams illustrate down here, whether you're doing the top left corner, top right, bottom left or bottom right corner. So there's 4 options, and then whether you want to climb or conventional cut, so you've got a total of 8 there. And what it actually does is it guides you through in very small steps. You end up with a kind of a staircase like feature. So let's say if we take this part, so if we wanted to take that corner off like that, obviously we couldn't move the hand wheels to smoothly go around that corner. So you tell it the radius and the tool diameter that you're going to use, and the fact that you're cutting in an XY plane, so we'll explore that a bit more in a moment. And then it ends up sort of exaggerated, cutting like that. So it sends you to a number of predetermined positions, but it never cuts into the part, and then you just have to file and sand that smooth again. So that's and it's similar for the straight line one as well. So yeah, so if you wanted to put a chamfer across there, you'd end up going in little steps like that, and it would guide you to each of those different coordinates, making sure you don't go into the part, and then you just have to file that flat again. So if you haven't got a CNC machine or you haven't got a rotary table, then that is an option. Now I mentioned XY plane, so if you think about if that's X and that's Y, so on this part coming this way would be Z, and it actually has the function such that you could put a radius on the edge of here like that. So you're taking that bit off there. So there's a few things you need to set up to do that, but you're basically doing the same thing, and you're going to staircase cut that like that. But if your part's down on the table, you're actually cutting an arc in Z, and the same thing with the angle as well. So it's actually quite versatile and quite a neat feature really. Let's talk a little bit about actually choosing a DRO for your machine, because sometimes that can be a little bit stressful. But I think in this case it's actually relatively straightforward, because basically they sell these DROs in increments of 50 millimeters, and the name they give them is the effective measurement range that you can take. So the way you work it out, so let's pretend this is your machine, this is the part that's moving. It might be a saddle on a lathe or a XY table going up and down, left to right, whatever it is. This is the part that moves a certain amount between 2 dimensions. So let's say this moves 380 millimeters in total. So you'd measure that, or you might know that if you're building the machine, whatever it is, and those are referenced down here. Now there's 2 things you need to know. Well, first of all, you need to round that up to the nearest 50. So in this case, we definitely know we need a 400 millimeter scale. Now in principle, there's nothing stopping you putting a bigger scale than you need for some future expansion, or if it makes it a bit easier to fit between 2 mounting points, it will just measure some portion of that, so that's no problem at all. But obviously if it's too small, you can't use it. So you round that up to the nearest 50, so in this case we've got 400. So the 2 things we need to know are, what's the distance between the mounting centres, so and what's the overall length. So if we start with the overall length, well, we call this the measurement length, so this is ML, and then the 2 formulas are, this total distance, edge to edge, is ML plus 142, so 142 extra on top of the measurement length, so in this case it would be 542. And then the other one you need to know is the distance between centres. So again, you take your ML and you add 124, and that's the distance between the mounting holes, so that would be 524 in this case. So whatever your ML is, add that number for centres, add that number for total length, and that gets you the rough package. Now you need to go onto the website, and it will give you the width here, the size of the head, the length of the head unit, the reader, and so on and so on. And then you draw that in the CAD and make sure the part's going to fit. But in terms of selecting it, find the movement of your machine, round up to the nearest 50, call that your measurement length, between centres is 124, and the total length is 142. There's one final thing that's worth pointing out with these readers, depending on how you're going to mount them. So you can mount them a couple of ways. You can see in the end you've got holes all the way down there. If you mount them this way, so in line with the head, that is an M4 slotted hole. And if you mount them this way, or that way, so on the side of the machine, that's an M5 hole. So do be careful, don't tap for M5 and then find actually it's an M4. That will ruin your day. So just be careful, just check whether you've got the M4 or the M5 fitting at each end. And then you've got various options on the reader head to take some kind of bracket usually. So there's a couple of fixings on there which are M4. All the dimensions are given on the website as to where these are. And then you've got those two there, alternative fixings, again M4 fixings down there. So there's a couple of options, a couple of ways to mount it. So I think now we'll dismantle this and we'll get the head unit hardware mounted up and see where we're going to put it on the drill press. We can also put the Z-axis scale on the back of the machine, so that's to measure the table height, so we can get that fitted. In terms of the table itself, these are the XY positions for the table. I haven't made the table parts yet, so we can't fit those. But if you have a look on the CAD model, you can see at the front here, we've got this scale, the long scale, the X-axis scale, and then on the side, you can just see the Y-axis scale there. But we need to make those parts before we can fit those. So we'll just have a look at the display and the Z-axis DRO over on the drill press. See you over there. So it's a bit fiddly to film because it's right around the back there, but you can just see I've just temporarily got the linear scale for the Z-axis there just behind the ball screw. So I'll just bring it in a bit closer. Alright, so I've just got it loosely fitted back down there. And then again just loosely fitted in there. So luckily I pre-drilled these holes and tapped them. I planned ahead of time. I knew where it was going to go. I got the CAD and made sure I tapped those because that'd be really difficult to try and do that. Now it's in situ, so that looks like it's going to work. So we'll just snug those up. As you can see, there's plenty of range of adjustment to get it lined up, but we'll just roughly centralise it for now. It's in there somewhere. There we go. Again, I'm just going to roughly align it to the edge for now. I could have picked some slightly shorter bolts. Anyway, somewhere about there. We'll adjust it later, just getting it roughly in line. Right, and then we've got our reed head in there. It goes up and down. Now the scales themselves didn't come with any instructions, but you see that red plastic piece just there that's just holding the reed head in place? I'm pretty sure you have to take that off, and then there's some shims that come in the kit that allow you to get that head position just right. So once we've got the mating bracket on there, we can get that set up. So we'll leave it for now. It's got pretty easy access to the two screws to take it out. Right, so I've just got this loosely assembled. So as you can see, I've got the cover on that fit over there. Still allows you to make all the connections and so on. And now it shows two ways of fitting this in the instructions. You've got the way I'm going to do it, which is with these little L brackets on the bottom down there, over to that adjustable sort of mounting foot over there. The other way shows two of those. Now they only show one supply one in the kit, so I can only do it that way, but maybe there's a different model, or you could order that specifically, I don't know. But we're going to put it like that. So everything you see here is supplied in terms of hardware. So there's a lot of washers. You've got your little split washer like that, just to try and stop them coming undone, and just washers around there and bits and pieces around there. You also get the two sort of M5 screws that go into there. You don't get the leveling grub screws, but I guess if you're building a machine like this and putting it onto something, you've probably got some grub screws. If not, they're not that expensive. The arm itself is actually quite long, which is good because that gives you options, but I did just briefly offer it up to the drill press, and I think I'm going to end up shortening it probably to about here, and I'll just re-drill that hole. This plastic end cap just pops out and we can put that in, so we can make it probably about that long. But for now, we'll just make sure it's all going to go together. I'll tighten these up and then we'll offer it up to the machine and see roughly where I'm going to place it. Just having a little look where I want to put the display. So I wanted it somewhere about here, reasonably close into the machine so it's not obscuring all the tools behind it. Not too low, so if you've got a big L-shaped or some weird shaped part, it gets in the way, so it's out of the way there, but then not too high, so you don't want to be reaching up and operating the controls. So somewhere about here, so about that location. So I will need to shorten the arm, but that's not a big problem. I'll just put some masking tape on here, and what we'll do, so we want it to be ultimately somewhere around there, tucked in fairly close to the machine so I can get stuff behind, and then always swing it out of the way if there's something really large up here. About there, which means somewhere about there. So I'll just roughly mark it for now. Okay. So what I can do now is just take this off and line it up there, clamp it, and then properly centre punch these. So these will be the two mounting holes here, and then we've got our, I guess they're M5 grub screws just to put some levelling in, but to be honest, I mean, this is a pretty flat surface, it's probably going to be okay just with those two fixings in there. And there it is, installed. I've decided to keep the arm a little bit long just in case I do need to reposition it. I can drill different holes to suit, so I'll just see how I get on with it. Okay, so there we have it. So we've got our two M5 cap heads just holding this on here. I didn't need the levelling screws because that's okay. I drilled another hole in there just so I could put the display a little bit closer. I decided not to cut that off. One, I can move it around like that, and two, if I cut it shorter, I'm bound to want it longer once I finally get used to using it. So we'll leave it like that for now. Very easy to cut it if I need to. Okay, now the bit I wasn't too sure about. So what I want to do is when I press the buttons, I don't want the display to move away. So I've tightened this up about as much as I dare because these didn't feel massively strong. Felt pretty lightweight. So we'll see how we get on. So I've pinched that pretty tight to try and hold that, but as you can see, it's only holding on a small area. So let's see what happens. So let's say we want to do a whole pattern. It's starting to move out of the way. Let's see if that... Yeah, if you push it really hard, especially if you come over here. Okay. What I need to do is find a way to secure this arm. I wonder. Right, let's try that again. Oh, lovely, yeah. Yeah, that's not going anywhere. Well, I've just plugged in the Z-axis scale. We've got it connected to the wall. Let's switch it on. Okay, so if I press the buttons, it should stay where... Yeah, perfect. Okay. And we'll move the scale up and down. Oh yeah. Yeah, very happy with that. I think it's going to come in very handy. Okay, let's give a summary of this DRO system that Banggood sent me with the 3 linear scales. I really like the display. I particularly like this updated model where they've clustered all the buttons together. Got a nice clear display, nice clear layout of all the functions, really easy to operate. As you can see, we went through all the different functions earlier, fairly straightforward. The scales themselves feel like really nice quality, just plug them in, nothing to set up, works straight out of the box. We've got the protective cable on there, everything's got a nice finish on it, so looks really good so far. So let's summarise this unit. Would I spend my own money on this particular unit? Absolutely. I think it's really good. I've been impressed with it. I like the clear display. The buttons are clustered together here. The functions are all laid together as well. We went through those a bit earlier. Yeah, look very straightforward to use. In terms of the scale itself, nice quality scale. Plug and play, works straight out of the box. It's got the protective cable on it. We've got the mounting hardware as well. Yeah, no problem at all. Only negatives were this chrome plating on here wasn't the best quality, but actually now it's on, probably blend in, it's okay. If that bothers you, you could make another one of those, but actually now it's on there, it's not too bad. The only other negative really is this cable you get sent. So you've got IEC connector on there, you've got this flat bladed pin one on there which goes into this travel adapter. I'd recommend you swap this out for a UK compliant plug. But apart from that, really like it, highly recommend it so far. So I think that wraps it up for this video. Hopefully you've enjoyed it. Let me know in the comments below, it'd be great to hear what you think, and we'll see you next time. Drill press conversion, and so the whole, somebody's car alarm going off. Thank you.